Hey Python enthusiasts! Welcome back to the 100 Days of Python series. Today is day 47, and we're diving into unsupervised learning with a focus on dimensionality reduction. We'll cover the basics of dimensionality reduction, explore principal component analysis, PCA, and use t-SNE to visualize high-dimensional data. Let's get started. Dimensionality reduction is a technique used to reduce the number of features in a dataset while retaining as much information as possible. This is crucial for visualizing high-dimensional data and improving the performance of machine learning models. Here's a simple example of a high-dimensional dataset that will reduce to 2D for easier visualization. Principal component analysis, or PCA, is one of the most popular techniques for dimensionality reduction. It transforms the data into a new coordinate system where the greatest variance comes to lie on the first principal component, the second greatest variance on the second component, and so on. Let's implement PCA using Python. Let's run the script to see the output. t-SNE, or T-Distributed Stochastic Neighbor Embedding, is another powerful technique for visualizing high-dimensional data. It's particularly good at preserving the local structure of the data. Here's how you can use t-SNE to visualize high-dimensional data. Let's run the script to see the output. And that's a wrap for day 47 of our 100 Days of Python series. Today, we explored dimensionality reduction techniques, implemented PCA and t-SNE, and visualized high-dimensional data. If you found this video helpful, don't forget to hit the like button, subscribe, and ring that bell for more awesome Python content. See you tomorrow for day 48. Keep coding and happy learning.